Hi everybody, we're going to do some quick notes on features of functions. This first section you actually don't have on your notes if you have the original version of the notes that I gave to you in class on green paper today. So what I want you to do is pause the video and flip to the back of your green notes. There's an empty space on the back and I want you to copy down what is on this slide. Okay, so now going forward, let's fill this in. To determine if a graph is a function, so is being the operative word, we will use the vertical line test. This is only if we have a graph. We're going to talk about some other ways and other representations that you'll see in some notes that are for tomorrow, but for today we're just looking at graphs. So if you can draw a vertical line, hence the vertical line test, anywhere on the graph and have it touch the graph in more than one spot, then the graph is not a function. You will see an example of this in just a moment. If your vertical line can only ever touch one spot on the graph, then the graph is a function. So flipping to the next, go ahead and pause the video again and draw a rough drawing of what these two graphs look like. Basically, the only part that I want you to draw is this and this. You don't need to get all technical with the numbers and the dots and everything else, just those general shapes. Same thing here and here, just draw that rough sketch. I'm gonna go ahead and erase so that I can write on it, but that way you know what to draw. So for the vertical line test, we said draw a vertical line. So if I draw this vertical line right here, and I can pick it up and move it. Oh, I guess that's not moving it. Let's go back. Anywhere that I draw a vertical line on here, I am going to see that it's going to touch more than one space. Touches here and here at the same time. Touches here and here at the same time, touches here and here at the same time. That means that this one is not a function. Now this next one, if I were to draw a vertical line anywhere on here, it only ever touches one spot. So right here, it's only touching once, right there, touching once right there, and once right there. So as such, this is a function. Okay, next in domain and range. So domain is the set of all possible x values. On a graph, we're looking at the farthest left value to the farthest right value. Sorry, that was written very badly. Left. So from here over to here. If we're talking about range, then we're talking about all possible y values. So from lowest to highest. So we're going low up to high. So as an example on here, the domain, farthest left x value is here, farthest right x value is here. So the domain would be from 1 to 14. For the range, the lowest value is right here. You can see it right here. And the highest value is right here. This looks like it's going by ones, so this would be 27. So from 20 to 27. Okay, so let's go back to this domain and just mark on the graph a little bit. So the 1 came from right here, and the 14 came from right here, so that you can kind of see the left to right for the domain and then we have the lowest to highest over here. Okay, so next bit of notes is notation. You're going to write, instead of writing it in words like you did here, no, that didn't work very well. Instead of writing it in words like you did on this slide, over here we're going to learn about interval notation, and then after that we're going to learn about inequality notation. You're going to see both of those notations throughout this module. So interval notation is going to be use parentheses if a number is not included. On a graph, it would be only if there's an open circle or empty space. Brackets we use if the number is included, where if we have a closed circle or just a regular line. So for example, if I draw this line right here, then this point right here is included, or here is included, included. All of these points along the line are included, so those would be brackets. Inequality notation, we use the greater than or less than if a number is not included. Same parameters on a graph, open circle or empty space. Greater than or equal to, remember from our inequalities unit, means that it is included. So the number is included, so it's closed or part of the line. And on graphs, because we have graphs that go forever and ever and ever, we have, let's see, choose a color here, shown on graphs with an arrow. When a graph extends off the grid to the left with an arrow, or to the bottom for the range, then it's negative infinity. And if a graph extends off the grid to the right, let's erase that. Started to write the wrong word. Right or up, then that would be the domain or the range going forever. Example, number 1 says, is this a function? Hint, remember the vertical line test. So one tricky spot is right here, because students tend to say, oh, there's a point right there and there's another point right there, so they default to no. But remember, this one is open and this one is closed. So for my range, I'm going to go -3 to 5. Now, this isn't included right here, so I have a bracket over here also. That's a coincidence that these are two -3 and -3. One of them is on the x-axis and one of them is on the y-axis, so it's not always the same. Now, the 5 is going to have a parenthesis on it because it is an open circle. Not because it's an arrow like in the domain, but because it's an open circle. So now this would correlate to -3, less than or equal to. Now I'm going to use y because y is the range values. And then less than 5 because of the open circle. Now, this next piece, you're actually going to do more notes on this tomorrow, but we will talk about it because it's already on these notes. So this f of 0 is basically y equals what when x equals 0. So x equals 0 is right here. So the y value of the function when x equals 0 is this right here because it's closed. It's not this one because that one was open. Oop, keep changing slides here. not that one because it's open. So y equals 0 when x equals 0 would be the answer for that one. Okay, in the home stretch here. So absolute minimum and absolute maximum. So absolute minimum, this is the xy point on the graph that is the lowest on the graph. So the lowest value, if you're asked for the lowest value, is the y component of this pair. The absolute maximum is the xy point that is the highest point on the graph, and likewise the highest value is the y component of this pair. You'll see an example in just a second, and we're almost done. Okay, so notice there was a typo on the original that I made copies of, so please fix it. This should say absolute maximum right here. I don't remember what it said before, but fix it to say absolute maximum. So the absolute minimum here is going to be this point right here. So 7, 20. And the lowest value is 20. Now this graph tells a story, and this is temperature, so we would say degrees Celsius because that is the degrees Celsius here on the y-axis. So the absolute maximum is this value right here, which is a 12, that looks like about 27. So 12, 27. And my highest value would be 27 degrees Celsius. So what these are saying here is on day 12, we had a maximum of 27 degrees. And what this one is saying is on day 7, we had a minimum of 20 degrees. All right, see you in class tomorrow.